It's a pleasure to be here. I chose this title, Dreaming of Tenure and IPOs While Patients Die, because I want to lift the veil on several illusions about the proximity of and affordability of personalized medicine. And I'm driven to consider this because all the way back from times as being a pediatric oncologist, I've watched those shortcomings. So this presentation is for you, Timmy. We have been talking about the approaches that have been emerging that have allowed us to think in different ways about health. And you've seen some examples about the power that comes from being able to generate massive amounts of omics data. And you've seen some nice examples of using network modeling to identify diseases and to look at another sort of completely indirect, but fortunately proximal adjacency, which is the concept of using IT infrastructure and cloud compute capacity, which gives the ability to generate open approaches to biomedical problem solving. Similarly, you'll hear about, if you don't already know, the nascent movements that are underfoot to give patients more control of their private data, genomic data. John Milbanks is going to talk about this tomorrow. And also, as you just heard, a very important complementary area, which is the concept of social media allowing citizens and allowing researchers to solve problems by using gaming, by using different approaches. When we see a visual illusion, we can recognize it. I want to consider several similarly potent illusions that are philosophical illusions and commercial illusions. When you go and you open up the bottle on a bottle of medicine, you expect a certain level of certainty that that drug is going to work. And we take comfort that the FDA and austere bodies have gone through that and sort of certified this is going to work, it's approved. But there's an illusion here that I think is worth referring to as the genetic illusion. There's an illusion that actually we all have the same disease, that when someone says this is for Alzheimer's or this is for breast cancer, and hundreds of billions of dollars are spent in developing the drug before approval, but then when you get right down to it, most drugs don't work. Many cancer drugs work somewhere in about 1 in 5 of the patients that get them. 4 of them, it's not working at all in. But even if you go to drugs such as the statins, billion-dollar drugs given to millions of patients, as I think you know, less than half the patients who take a statin get a benefit in terms of having a lowered risk of heart attack. And so we're spending a lot of money developing drugs, but then we seem to be in denial with regard to the fact that they aren't quite for us, and people aren't really watching the fact that that's happening. And I should know, as Colin mentioned, I spent 8 years in pharma working in discovery and development in oncology, and these institutions are filled with brilliant scientists of good intent. It's just they're not necessarily focused on things that I think are going to benefit patients. Secondly, we have witnessed what can only be described as sort of the shock and awe technology as going from deciphering the DNA code to having it become a commodity. And it's almost as if we have, in a couple of decades, gone from like the physicists watching falling apples to being able to look at tracks of subatomic particles. I think looking back in history, we aren't in the moment able to comprehend the amazing shift in terms of capabilities of being able to decode what's going on. But these technologies have allowed us to begin to shift from thinking of diseases simply in terms of symptoms, and now to look at them in terms of molecular networks, to look at them in terms of a pathway. But the illusion that I fear here is that this information is considered to be pressure tested. It's considered to be ready to be used in terms of guiding effectively drug development. And the reality is that we've just sort of like wandered into this new world where there are altered component lists, but we really should be humbled by the complexity of this omics world because the ability to navigate that, to move through it, are the things that we really have yet to be able to do. And again, I feel as if I should know this because I have spent time driving companies that look at patterns, that have been trying to be on the cutting edge of that. But you might go, wait a second. This is a little pessimistic, Stephen. Maybe we should be looking at institutions and the power they're going to be able to bring to solving these problems. And in that instance, I think the illusion here is that we consider our academic institutions well positioned to move us into this new world that is driven by big data in health. The illusion is that the NIH, with its $32 billion budget, is at all well positioned to be able to help us enter this age. And the reason is that academics live in a world where the reward system is one that is akin to early tribes, hunter-gatherer societies, where basically, as Garrett Fitzgerald said at the University of Pennsylvania, who runs translational medicine there, he said, academics are punished for sharing. They need to be first author, they need to be on a one-name journal in order to get their tenure. And universities still function a little bit like the tribes in Warhammer games. Our brightest minds go around going, I've got to go to Stanford, I've got to go to here, sure wouldn't want to go there, because there is not a flow of the knowledge, of the tools, of the resources that actually should be able to be made available no matter what institution you're working on, or from which you're. And again, feels if I should know because I've taught at several of those institutions. So then we're close to Silicon Valley, and I think there are a number of people who are in the audience who are hoping that the high-tech world, the VC-driven high-tech world that's developing apps, is going to be able to step in and have a major role in terms of being able to shift how we're going to enter this world. And actually, I'm going to pause here because I actually think those apps are going to be fundamental for being able to make that transition into that world. The thing that I'm worried about, which I think is an illusion, is that the data that they're using to build models is actually sufficient to be able to offer patients what they need. And to that point, there was an article in the Atlantic Monthly last month which talked about melanoma and the apps that are abound for being able to detect melanoma. And the apps do a remarkable job, a pretty good job, of being able to say, this is something you should have looked at. But in fact, that's being done by millions who then go to a local doctor or dermatologist, have $1,000 spent, and what comes back 19 out of 20 times is, you're fine, there was no need for that. So from the standpoint of an efficiency in the system, the power of the app is not there. It's good as an alarm, as a way of looking at what people should do in educating, but it's not providing information. And that's because our ability to build models of disease stands right about where chemists were in the 17th century before the periodic table was able to be deciphered. And so to that extent, the real problem is that we lack the models in order to be able to make the insights that we need. And 2 weeks ago, I was in New York City with a friend from India, and we were talking about corruption in the world. And we talked about corruption in India, and he said, there's corruption in India, money passes hands, but I consider that fancy corruption. The corruption that I worry about is the corruption of denial, where people are working in ways and they just aren't even aware of the real problem that exists, which if you aren't aware of it, you can't tackle that. And in about 50 years ago, Eisenhower, Republican president, general, was looking at how he could get benefit to the troops, how the troops could be served. He became very concerned about the loops that were going on between certain groups. And basically, as is said here, he said, we must guard against the acquisition of unwarranted influence, whether sought or unsought, by the military-industrial complex. He coined that term military-industrial complex, the iron triangle that went on. What I worry about is that we have a 21st century permutation of that, which is a medical-industrial complex, where physicians and scientists gain support and are working within institutions which have support that help pharmaceutical companies. And this iron triangle is actually working very well for most of the participants that are in that iron triangle. But I ask whether in this data-rich world that we're moving into, is that one that is actually serving the patient the best? Precision medicine is the term that has been coined by the National Academy of Science to represent this world we're going to move into, moving away from symptoms. And that precision medicine world, I think a lot of people are expecting that existing institutions are going to be able to take us to there. So I call that having faith in institutional incrementalism. And then there are a number of biotechs and other companies that are thinking, if I could just solve this particular problem, I may have to close that off, but at least I'm being able to solve a problem. You should be glad that I have that. And I think those are often proprietary short-term solutions. I'm going to argue that actually we need data flowing and open systems for sharing that's in a commons. And a commons is worth having when there's a common threat and when it's in the best interest of everyone to band together. And so I'm going to argue that actually that type of information commons is needed. You'll hear more about that, as I mentioned, from John Wilbanks tomorrow. But really what we're talking about in that is actually a transformation in the role of what a citizen is expecting their own role to be. And here this triangle is a different triangle. It's one in which citizens can simultaneously take on different roles. It's not as if the scientist is the only one who can do research, or the funder is coming from here, or that the citizen is only able to be a patient. And I think that if we can look at different ways to activate patients, activate citizens so they can work with researchers, that's the only way we're going to get to that type of solution. So 3 years ago, I left large pharma and began working on what would it take to build an information commons. And we felt as if that we needed to have a technology platform, we needed to work on governance, challenges, and impactful models. And picture Sage Bionetworks, about 40 people, nonprofit foundation, as a test bed, alpha tester, piloter, incubator for these that we hope will be used by other groups. One example is in order to share the data, you have to have the technology that allows you to do that. So we've developed a system called Synapse. It's in alpha beta testing, but it allows data to be shared among academics with rewards such that that data doesn't have to wait to come out in an academic journal. So think of it as a compute space, and think of it as allowing rapid learning. We've been running a project this past summer that you can look up on the site on breast cancer that allows a cohort of 2,000 patients where there's genetic and clinical information to be put in the public domain. And then anyone from around the world can get to that data and build a classifier for women and their risk of going on to metastasize. That effort, which we started on July 16th, took 6 weeks for a single individual to actually outcompete the classifiers from the programs that had been developed at Harvard, at Stanford, at Columbia, et cetera. 6 weeks for an individual in that challenge to be able to outdo those classifiers. But the one I want to end with is one that's just taking off. We're just starting it, but it has more energy than anything I have seen. Remember the description of melanoma and how the apps aren't working as they could. So several groups have come together and are asking, what could we do with medical information in a system as simple as melanoma, where the photograph that could be taken is one that you could take on your iPhone or Android, where you could get the image, the path image that represents the disease as a single entity, and the path report. This triplet of information is actually all you need in which to build a classifier. So now imagine that you could put that up into the cloud, that you could ask people from around the world to begin to contribute that, and to start running challenges in an open way and modeling that to see whether, in fact, you could come up with the real classifiers that then the apps could live off of. So that type of process, I think, is one to think about, and the value in other disease areas. So basically, I'm going to end with this. We have a choice. Shall we continue to dream of tenure and IPOs while patients die? Or should we consider a place where patients come first and where citizen funders, researchers can come together to build the equivalent of medicine 2.0? And we are about to exit a world that we take for granted. We have to be able to step out of our world of illusions. And the 5 trends that I began with lead to the last statement, which is these 5 trends can enable an open community of impatient citizens as patient researchers and funders. Thank you very much.